Good morning, students. Today's class we are going to discuss electric dipole placed in uniform electric field. Electric dipole placed in uniform electric field. Suppose it is a uniform electric field. Uniform electric field means the electric field is uniform at every point according to their positions. Okay? Suppose it is an electric dipole. It is positive charge and this is negative charge. Direction of electric field is always acting positive to negative direction. That means it is this end is positive and this end is this end is positive and this end is negative. And magnitude of charge is Q. It is negative charge. This is positive charge. Electric field is E. Force applied on this charge can be found by F equals to E equals to Q by F upon Q, force experienced per unit charge. So F is equals to Q into E. Force acting on this charge is QE. It is acting in this direction because for the positive charge, electric force and electric field both are acting in same direction. So QE. And similarly, this end is positive and this end is negative for electric field and this is negative charge, then force acting in this direction. QE. Magnitude equal and electric field is uniform, that's why both forces are having same magnitude, but they are acting in opposite direction. And the direction of this force is in this direction, so we can draw a line. It is an acting line of the force. And this is also acting line of the force. Okay. Now the perpendicular distance between both forces is this. Perpendicular distance between both forces this. It is a perpendicular distance. Suppose that we assume A, B, C. In triangle ABC, electric dipole makes an theta angle with electric field. So in triangle ABC, sine theta is equals to perpendicular upon hypotenuse. Perpendicular is BC and hypotenuse is AC. So BC is equals to AC sine theta. And here AC is the separation between the dipoles is 2A. Okay. Now AC equals to 2A. So BC is equals to 2A sine theta. Right? Now we calculate torque. So torque is equals to force into perpendicular distance between forces. Here torque, sine of torque equals to this. Force is QE. Perpendicular distance is equals to BC between two forces. these two forces and perpendicular distance is BC here. So this can be written as QE dot value of BC equals to 2A sin theta. Okay, so torque is equals to Q into 2A into E sin theta. So Q into 2A is equals to dipole moment P. Q into 2A. It is a dipole moment. So torque is equals to P E sin theta. Torque is a vector quantity, dipole moment is also vector quantity, and electric field is vector. So that direction of dipole moment is always taken from negative to positive. It is dependent on the distance d 2a. So torque vector equals to P cross E. It means PE sin theta, where P cross E equals to PE sin theta. So what is the direction of torque? In this case, the direction of electric field is positive to negative. Direction of electric field is positive to negative. Direction of dipole moment is taken from negative to positive. That means this is the direction of P. Here this is direction of E. And what is the direction of dipole moment? So P cross E. P cross E, direction of torque is acting right hand screw. P, E and E. PE, torque is acting vertically inward to the board plane. Okay. And a very important thing is here. When electric field is uniform, that means the net force acting on the dipole is zero, because this force QE is equals to this force, because electric field is constant at every point. That's why net force on dipole is zero, but torque is acting. Listen carefully. When dipole placed in uniform electric field, net force on the dipole is zero, but torque is acting. If this dipole placed in non-uniform electric field, it means electric field here and here is different. In this case, net force on the dipole is not zero and torque is acting. It means torque acting in both of cases, but force in uniform electric field is zero, and in non-uniform electric field it's dipole having some force also, resultant force. Okay, now we are taken here some important cases, special cases. Case number 1. If theta is equals to 0 degree. Theta 0 means when dipole makes an angle 0 degree, when angle between dipole moment and electric field is 0. Suppose it is electric field, here is a dipole, negative and positive, and that direction of dipole moment is also in this direction. So here P and E are acting in same direction. Here E and here P are acting in same direction. So theta is 0. That's why net torque on this dipole is 0. PE sin 0 degree, sin 0 equals to 0. That means torque is 0. Okay. When electric dipole placed in uniform electric field, in this case, the net force is also 0, net force 0 and torque is also 0. Okay. If theta is 0, right? This case is in this situation, dipole considered as a stable equilibrium. Stable equilibrium means equilibrium means net torque 0, net force 0, and it is a stable, because in this situation the potential energy of a system is very low. That's why it is called stable equilibrium. And now case number 2, Here we can write here. Case number 2. If theta is equals to 90 degree. Theta 90 means when electric field is acting in this direction, this is the direction of electric field, and dipole is placed in this case. Suppose this is negative q, positive q, and direction of dipole moment is in this direction, negative to positive. Here is angle theta 90. Sin 90 equals to 1. That's why torque is PE sin 90 equals to 1. That means PE. In this case, torque is maximum. So when electric dipole placed perpendicular to the electric field, it's experienced maximum torque, but net force is 0. That's why maximum torque acting in perpendicular situation. Case number 3. If theta equals to 180 degree. 180 means when electric field is acting in this direction, and this is positive charge, this is negative charge. So direction of dipole moment acting in this direction, negative to positive. This is the direction of dipole moment, and this is the direction of electric field. In this case, angle between them is 180. So sin 180 equals to 0. Now torque is also 0, because sin 180 equals to 0. This is also in equilibrium because net force is 0 and net torque is also 0. But this situation is, in this situation, dipole is in unstable equilibrium. Unstable equilibrium. So here we have discussed here 3 cases. First case, when theta is 0, like this. This is called stable equilibrium. In this situation, net force and net torque both is 0, and this is called stable equilibrium. If theta is equals to 90 degree, then net force is 0, but net torque is maximum. And in this case, if theta equals to 180 degree, then net torque is also 0, net force is 0. And this is called unstable equilibrium. In this situation, the potential energy of a dipole system is maximum. When the potential energy of any system is maximum, it is called unstable, and potential energy is minimum, then it is called stable. In this case, potential energy is minimum, and in this case, potential energy is maximum. Okay, this is the electric dipole placed in uniform electric field. When this dipole placed in non-uniform field, the net force is not 0, but torque is active. But in uniform electric field, net force is 0 and torque is also active. Okay. Now for today's class, this is over. And for next class, we will discuss on for the next topic, we will discuss on next class. Thank you very much.